So we talked about the addition rule if everything is disjoint or mutually exclusive, meaning they have nothing in common, right? What if we just have a general addition rule? Because not everything is disjoint or mutually exclusive. Okay, so if I want to find the probability of E or F, oh my, that one looks crazy, doesn't it? F. Then or still means addition, but I've got the probability of E, the probability of F. But if I have something that's in common, I have to subtract what's in common. This part right here stands for what's in common. Because you cannot put those together twice, right? You're not counting for something twice. If something can be represented by both events, E and F, it's what's in common between the two, then you have to subtract it off because you can't count it twice. That's the whole moral of the story. This way we don't count that twice. So, suppose a single card is selected from a deck. Compute the probability of a king or a diamond. A king or a diamond. So we know I'm going to squeeze this down so we can see our cards again. Look up here. If I've got a king, that's in this last column. We've done that a couple times now. We know that that's 4 out of my total 52. And then where are my diamonds? So look what happened here. I'm going to make this one highlighted so you can see a little bit better. How many diamonds are there? There are 13. But do you see how when I'm looking at my kings, my kings and my diamonds, I have an overlap in the corner, a king of diamonds? Well, you can't count this twice. Right now we're counting that number twice. That's why we have to do this subtraction. That is what is in common. I'm going to make this bigger so you can see it better. So we have 4 kings, 13 diamonds, and we have 1 king of diamond, so we can't count it twice because we've already counted it here, that card here. We counted that card here. Since we counted it in both places, I have to take one of them away so we can only count it one time. Do you see what we're getting at here? Okay, that's why you subtract off what's in common. So then you add those together. 17 minus 1 is 16 over 52. And if you reduce that fraction, we get 4/13. And your calculator will do that for you too, right? Good. Okay. Does that make sense? Taking out what's in common there. That's the general addition rule. Still the word or. We're still going to be adding. We just have to subtract off what's in common there. Cool. All right. Oh, I keep hitting the wrong thing. Cool. Now, let's look at this table. This table is really awesome because it is called a contingency table. And sometimes it's called a two-way table. It puts lots of information all in the same place. So the row in this particular table here, my rows, that is marital status. The columns are gender, right? So we're saying, okay, we've got this, I wanted to go under. This piece of never married, you can say between male and female, you have 2 pieces of information that goes with one set of data. That's why it's called a two-way table. Or it's just called a contingency table. It's just what it's called. All right? All right. We are still going to figure out probability. Probability is part over whole. So in order to figure out how many people we're talking about total, we need to do some addition. Let's make this red so you can see it better. Let's add those up. So in your handy dandy calculator, add those up. Let's figure out how many total people we're talking about, males and females. So add those up and you get how many? 126.9. Good. Add up females. How many of those do you get? 133.2. Good. So if I want to figure out how many total people we are talking about. Now, granted, this is in millions, right? This is in millions. But how many total people that we're talking about, you add those two together, and what do you get? 260.1. Yep, and it is in millions. But it's that 260.1, which we need to know because it's part out of whole. Okay, so if I want to determine the probability, I already lost my space, that a randomly selected U.S. resident of 15 years old or older is male, that we're looking at because that's what my criteria is, then my male column is here, so the quantity of male out of my total. Do you see how it's always part out of whole? 126.9 out of 260.1. I know it's all in millions that we're looking at, so we don't have to write the word million there because it's all in the same unit. And it's probability. Probability is a decimal between 0 and 1. Let's take it to 3 places. What do you got? If I do this division to 3 decimal places, what do we have? 0.487. Good. So that's the probability based on this data that we're talking about, a male out of the total. Okay. Now, determine the probability a randomly selected resident is widowed. It doesn't say male or female, just widowed in general. So that means I'm taking this column. Pardon me. This row, 3.3 plus 11.9 is going to give me what? How many is that? 15.2? That's widowed. 15.2 million, we know, but that's widowed. So the probability of widowed is 15.2 out of my total. That's why we figure out that total first. So 15.2. Oh, dang it. I rounded incorrectly up here, didn't I? I just saw on my paper. This is 0.488. Did you guys hollering at me? Hey, wait, you're not rounding correct. You're on it. You know, I'm wrong. You're right. That's good. 15.2 here divided. Now let's make sure we can round this one correctly. What do you get? I've got 0.58. Is that what you have? You got to keep me on my toes. Keep me on my toes. All right. Okay. Now, I'm going to scoot this up a little bit. What if I have determine the probability that a randomly selected U.S. resident is widowed, ooh, there's that word again, or divorced. So the probability that this person is widowed or divorced. So let's figure out widowed we've got. In order to figure out divorced, let's add those up. What's 12.1 plus 16.1? 28.2? Okay. So widowed is 15.2 out of my total. Divorced is 28.2 out of my total. And then what do you get? Well, I'm going to 43.9. Pardon me, I said the wrong thing. 43.4 out of 260.1. I'm just putting that in there so that you can see. And then if I take that to a decimal, because that's what we're looking at, right? Decimal to 3 places. And your homework will say, oh, to certain places, whatever it is that you're talking about. Right? Widowed or divorced. There was no gender associated with that one, right? So I didn't look at male or female in particular, just widowed or divorced. To disjoint. They don't have anything to do with each other. They're not crossing over in columns at all. They're 2 separate rows. I don't have to worry about any events in common, right? Nothing's in common there. Okay, I'm going to scoot this up. I still want to be able to see that. So look at our last one. Determine the probability that a randomly selected resident is male or widowed. Male or widowed. See, we got some overlap going. That's where we use the general rule, right? So if they have something in common, then you have to subtract that. Let me make this to where we can squeeze it in here and get all of our info on there. The probability of male or widowed. So we've got male, 126.9 out of my total. Female, oh, no, wrong. Widowed, 3.3. No, lies. Male widowed total is 15.2. I got ahead of myself. Minus what's in common. That's where we're doing our 3.3. My brain was moving faster than my hand. You can't skip those steps, right? We got to take our time, make sure that we've got that set up. So male plus the widowed, because that's a male or widowed, putting those together. But because they have that 3.3 in common, we have to subtract that off. So all of that together, if you plug that into your handy dandy calculator, it's got the same denominator. So you just add and then subtract off that 3.3 will give me 138.8 according to the calculator. Then you give it to a decimal to 3 places. 0.534. Do you see the difference here? I really like this C and D because you can see disjoint, nothing in common. And then D, you can see where we use that general rule because you can't double count what's in common. Between the row and the column together, you have to subtract off that what's in common. The only time you use the subtraction is if there's something in common. If there's nothing in common, then you don't have to worry about it. All right? Okay, awesome.